We are quickly wrapping up this chapter. We are now on Chapter 1, Section 5, Equations of Proportional Relationships. Have you noticed that for the last 3 lessons I have been wearing the same shirt? I'm feeling a little scruffy. That's because I'm doing all 3 of these lessons on Saturday. I got my comfy shirt on. I didn't bother shaving this morning because I'm not doing anything cool like, I don't know, teaching y'all out in public and whatnot. So I chose to stay comfortable today. Pretty much my entire Saturday has been spent doing homework. Yes, teachers do have homework too. You guys know I ask y'all to do homework. I do it too, folks. I'm not asking a lot. So, with that said, let's see where we're going today. Students will write equations to represent proportional relationships, and we have a new vocab term right here. Right here. Proportion is an equation that states 2 ratios are equivalent. Now notice you had proportional, which 2 quantities are proportional if the ratios comparing them are equivalent. Proportion is very similar. It is an equation that states 2 ratios are equivalent. And with that, our pacing guide says we have a 90-minute lesson today. Of course, we're going to knock this out on video in a lot less than that, but in class, it's probably going to be about a 2-day lesson. So let's begin. At top speed, one of the fastest elevators in the world travels at 45 miles per hour. That just strikes me as gut-wrenching. I don't like the sensation of falling. Swing sets terrify me. And we're talking about an elevator dropping at 45 miles per hour? Not me. The equation y equals 45 can be used, grabbing the cat. Y'all hear her, here she is, Tilly again, can be used to find the miles y traveled in x hours. Suppose you could ride this elevator for 1 minute as it travels 45 miles per hour. How could you use the equation y equals 45x to find out the distance you will travel? These are the kind of things that we're going to be learning in this lesson. Are introducing the inquiry questions. How are equations of proportional relationships different from those of non-proportional relationships? And we're going to take and use a web sketchpad to explore this problem. Press the launch button. Does the relationship appear to be proportional or non-proportional? So let's hit our launch button here, and when we do, I'm seeing a balloon that's kind of moving, zigzagging back and forth as it rises, but it's making a straight line. It's going down into the origin, so we have a straight line right here that goes to the origin. That strikes me as being proportional. If we were to take and show the actual equation, you have y equals 0.345 times x is the equation that made that graph. I know that doesn't mean anything to you right now, but we will get there. Now we're going to do the same thing again with a new equation, and this one, when we hit the launch button, I said when we hit the launch button, here it goes. And our balloon is rising. Looks to me like it's making a very straight line, but does that straight line go through the origin? It does not. And that gives us this equation right here. Y is equal to 0.58x plus 10. Take a look at where it started. Instead of starting the origin, it started at the 10. What do you see right here? Plus 10. That plus 10 tells you where it's going to be when your x value is 0. If you multiply 0.58 times 0, put 0 in for x, then you'd have 0 plus 10. That's why where x is 0, y is going to equal to 10. And by the way, that one we just looked like is going to be non-proportional because it did not go through the through the origin. All right, we got another one. Let's see what it does. Our balloon is rising. It's putting dots on. It started in the origin, appears to be making a straight line. Yep, I'm thinking that one looks like a straight line. It started in the origin. If we were to look at it, it is y is equal to 0.46 times x. It is going to be a linear equation. It is also going to be proportional. So the answer to this one, yes, it is indeed going to be proportional. Now you pause the recording, answer these questions, and check your answers. Did you get it done? Well, the proportional ones were the ones that were not a plus or minus something. So these two ended up being proportional, and then the plus 10 ended up being non-proportional. Checking our answers, everything checked. We are off to a good start for this lesson. So, how are equations of proportional relationships different from those from non-proportional relationships? Pause the recording, type in an answer, and then we'll see what the textbook had to say. The textbook said the equation of a non-proportional relationship has a number added to it as a constant, like this plus 10 right here. In graphs of proportional relationships, there is only a value multiplied by x, such as this one right here that says y is equal to 345 thousandths times x. Now we're going to work on identifying the constant of proportionality in equations. Olivia bought 6 containers of yogurt for $7.68. The equation y equals 1.28 times x can be used to represent this situation where y represents the total cost of the yogurt and x represents the number of containers caught. Identify the constant of proportionality and then explain what it means. How would you begin solving this problem? Well, for me, I think to identify the constant of proportionality, all I'd have to do is multiply that 1.28 times 1, because that's going to give us where x is 1, y is equal to the constant of proportionality, right? Remember, we have that y over x equation we worked on last lesson. So with that, I just say, well, 1 times 1.28, 1.28 is your constant of proportionality. Let's see what the textbook has to say. Plan A, identify the constant of proportionality. Compare the two equations. Y is equal to kx. Now I do want to emphasize something to you. This y equals kx you see right here, we call that the direct variation equation. Down the road you're going to hear a statement that says suppose y varies directly as x, or y varies directly with x. Anytime you hear that equation or that statement, you're going to stop what you're doing and you're going to write y equals kx because you're going to need it. Now, where k is the constant of proportionality, therefore y is equal to 1.28 times x, so k became 1.28. K is also the constant of proportionality. So in the equation, the cost of yogurt, your constant of proportionality is 1.28, and ding, we got it right. So the 1.28 is your K value. It is your constant of proportionality. You could also use Plan B. Explain the constant of proportionality. The constant of proportionality has the same value as the unit rate. I believe this is what I talked about earlier. The constant of proportionality means that the cost of each yogurt container is how much? $1.28. That's where the X was 1 that I talked about earlier. Your Y was $1.28. So once again, your constant of proportionality is the same, $1.28. Two different ways to skin the same cat. Yeah, I'm talking about you, Tilly. So, how much would Olivia pay for 10 yogurts at the same rate? What do you know? Well, you know the constant of proportionality is $1.28. So, pause this recording and figure out the answer. So, my direct variation equation is y is equal to kx, where my constant of proportionality we've established is $1.28. And my x value, the number of things of yogurt that we want to buy, is equal to 10. That means y is equal to 1.28 times 10. That's going to be $12.80. 80 cents. That's some really easy math to do. All we had to do was bounce our decimal in order to get the answer. I do want to emphasize that this is big kid math. We're finally getting into some stuff that I like doing. It's called algebra. Alright, so we have got a formula, y equals kx. We're substituting values in for our formula, and we're multiplying, solving for y. Baby steps for algebra, but it's still some really cool stuff. Now, I want you to pause the recording, and I want you to work through this problem. If you need some help, we got a need help section right here that says, remember, the value of the constant of proportionality is equal to the unit rate. Write the ratio as pages over minutes and then simplify the denominator to 1. Pause your recording and solve this problem, checking your answers. Yeah, you too. Did you do it? Let's take a look at how I work this problem. Robert typed 2 pages in 15 minutes. The equation y is equal to 7.5x can be used to represent the situation, where y is a total time and x is the number of pages. Remember, they said that they wanted you to see it in the hint as time over pages, and we also know that we have learned before that you will write these as y over x. So we've got time over pages. We know that the constant of proportionality, we have that equation, y is equal to kx was a formula we have for direct variation. Our k value, therefore, is going to be the 7.5 that we're going to put in right here. Part B, describe the constant proportionality. This means that Robert types how many pages? It means he's going to type 7.5 pages every how many minutes? Every 1 minute. With that, I'm going to go back to my screen. We're going to take and plug in those answers and see if we are right. 7.5, 7.5, and 1. Check our answers. Good. Check our answers. Uh-oh. What did we miss on this one? That doesn't make sense to me. Oh, I see where I screwed up. It said he types 2 pages in 15 minutes. Uh-oh. I flipped my numbers here. So I should be typing 1 page in every 7.5 minutes. See, even Mr. Reeds gets in big hurries and screws things up sometimes. Let's move forward. You can use the constant of proportionality or unit rate to write an equation in the form y equals kx that represents a proportional relationship. You can find the k value, remember k is your constant of proportionality, by writing the ratio comparing y to x. To write the ratio and then solve the equation y equals kx for k. Now, they've got some really funky stuff thrown out here, and we're going to take a screenshot because I want to show you exactly what happens there, because this is kind of weird stuff, and we haven't done anything like that this year. Now, they start out with the equation y equals kx, and this is straight up algebra stuff, but don't be scared of it because it's so simple. So I'm going to take my y equals kx that they gave me, and I'm going to do what we call isolating the variable. In isolating the variable, you've got to do the same thing on both sides so that the variable you want to isolate is isolated. Our target variable is k. We want k all by his we would wants them. We ask ourselves, what is k doing to x? Well, k is multiplying x. What's the inverse operation of times x? That means to divide by x. And if I divide by x on the right, I also have to divide by x on the left. Now, let's take a commercial break. Stop that thought, and I'm going to go on a different train of thought here. If I had 3 divided by 3, what would I have? I would have 1. If I had 2 divided by 2, what would I have? I would have 1. So now I have x divided by x. What is x divided by x? X divided by x is 1. Just like all these was 1, x divided by x was 1. And that's what we have right here. X divided by x is a big fat 1. And then 1 times k is going to leave k is equal to y divided by x. That is exactly what they're trying to show you, the point they're trying to make in their information right here. Ooh, don't want that going. I'm not sure how we got quite that big. So you have y divided by x is equal to k, and that explains why it is that way. Important thing to note, the constant proportionality of the ratio y divided by x only works where x is not equal to 0. We're going to talk more about that later this year, but if x is equal to 0, that means you have a number divided by 0, which creates an imaginary number. Scary things happen with imaginary places. What is the equation for a proportional relationship where the constant of proportionality is 3.5? Well, or 3.25? Well, let's go back to our screen here, and we're just going to take and say that I know my constant of proportionality is 3.25. I know my equation for direct variation is y is equal to kx, and I know that y therefore will equal to 3.25 times x, and that would be your final answer. We are going to stop here for part 1 of this lesson. When we come back, we're going to learn about why JC bought 8 gallons of gas, or maybe not why, but we're going to deal with some constants of variation with that information. Come back and watch the second video.